All right, I think we have Mr. Islam, Zubair Islam is here, and I think that's the only person we have for this closing session. And it's Earth Observation for African Solutions to Global Challenges. Mr. Islam, if you could join us, please, on the main stage. I think you have to accept the invitation to join. I'm sending you that. Oh, he doesn't want to be promoted. Okay, maybe he's busy doing something else for right now. So anybody from the, who's listening who has a question in the meantime, Mr. Islam, right, if you could join us, there you are, all right. If you could join us, please. Please accept the request to join. Thank you, you're fabulous. And if you could turn on your camera, if you didn't get lost in cyberspace. Here you are, fabulous. If you could turn on your, I'm not seeing your microphone though. I'm not seeing your microphone. If you could turn on your camera, first of all, so at least we can show we can see you. All right, we're seeing both. If you could unmute and turn on your video, Mr. Islam, we'd appreciate that.
Good afternoon.
So folks,
good afternoon.
Here you are, fabulous. And you are at the University of Abuja. We're not seeing your camera. There you are, awesome.
Good afternoon.
Good afternoon. So welcome, welcome, welcome. You're here to talk about Earth observation for solutions to African solutions to global challenges. So the floor is yours. Would you like to share your screen?
Yeah, of course, I will share my screen now. Share.
Okay, fabulous. Go ahead.
Okay, and yes, and let me take my presentation. Please give me some presentation. It's here. And then, where is my presentation? No. So, yeah, let it. Okay, should I share my screen here?
Yes, please. Go ahead.
Yes, good afternoon, everyone. Well,
Yes,
this is
oops. Uh-oh, he dropped off. Maybe he'll be back soon. All right, while we wait for him to come back, I hope you students have been taking notes and have questions for our conversation. Here you are, you're back.
Yes, I'm back. And let me share my screen, share it. Okay, all right. Sorry for interruption.
All right,
so,
we're seeing it.
Yes, so the theme is Earth observation for African solution, global challenges. So my topic is drought and flood monitoring using the satellite data. So the is this QR code is visible to all of you, please?
Yes,
well,
yes, yes.
Yeah, so what I have done is I have used the satellite data to make the maps or to do the study for the drought and floods analysis in Nigeria. So the first one is the drought monitoring via enhanced vegetation index. Here the data which I have used is MODIS 13QI. So here the enhanced vegetation index, which is given here, and the energy, the energy which we use is the near infrared energy and the red energy. So the idea behind using NIR and red is that when this near infrared energy interacts with the green plants, most of the energy is reflected back and the red energy is absorbed if the plant is green. So we get the values, higher values where vegetation is green and the lower values where there is no vegetation. So normally the index ranges from -1 to +1. Above 0 is the vegetation. And if this is more, vegetation is more, it's more green. So there are many methods which we can use to monitor the drought condition of any area. Here I have used enhanced vegetation index, and the data which I have used is MODIS data. So let me come to my application here. In this application, there is a left panel given where we can select the states. We can select the observed period here. And then when we will click the standardized vegetation index, we will get the drought conditions, whether droughts are there or not. So in this example, what I did is I saw some areas in, I think, 2021, Sokoto, Katsina, Zamfara, and Kebbi state, where these are the droughts, significant dates. So if we take 2021 here, and here I have taken the exact 2021, and this is the time June to October. This is the time period. So what happens if a student is doing analysis of SVI, standardized vegetation index, and then it takes more time in data collection and then data analysis. At the time of data analysis, there are many things which we have to take into account, that the bad pixels and the pixels which are not acceptable should be removed or should be masked. So in this application, at the background, which I'm using the Google Earth Engine, such type of pixels are masked. So the image which we are getting are the valid pixels. So the confidence level will be higher that what analysis we are doing is correct. So here this is what we have. Observed period is June 2021 to August 2021. And this is the time of the drought condition in northern Nigeria. So the result will be here. It will give you, and in blue color, the drought is not there. We can look at the findings here. Yes. So the blue color, blue area is showing that okay, there is no drought type of thing here, and red color will show us that these are the LGS where the drought conditions are there. So the red color is the negative side, blue color is the positive side. The negative side means here the SVI, standardized vegetation index, has been, it's a declined side. So the red areas will give you that here this is the drought conditions, and we can look at the yellow color. Yellow color will give you the cropland areas. So in Sokoto, the yellow color is highlighting or giving you the area where there is a cropland cover. Now have a look at the data. We can have a data which are the LGAs where the vegetation is down. So we can see the LGAs and we can download the CSV also. So this CSV will help us for our further analysis. So this is the way the research or the analysis or drought monitoring will be very helpful. So this is the one method which I have used to monitor the drought, and this method is dependent on the standardized vegetation index. The second method which we can use is based on the precipitation, the rainfall. The idea is same. The observed period, that is observed period, which is in the hand of the user. User can define or give the observed period. So this observed period is being related with the same time window, like June to September, and it will see the baseline period, which is 2001 to 2025. So compared to the baseline, that is around maybe 24 years, the mean values will be correlated with the observed period, the same months. So the baseline period will give us the normal uh, green or EVI, normal EVI, the mean EVI, how much you are deflected from that mean EVI. I mean observed versus the baseline. So here this is the idea which we are using to monitor the drought condition, which we can use to monitor the drought conditions. So this is all yellow area shows the cropland area, which is Copernicus data. Only cropland area is extracted, and here given using this yellow color. And then we can see where the vegetation got down. So these are the LGS, especially the name of the LGS, Tureta and Kajiji, where the vegetation gone down in 2021 drought. And now let's see another method of drought monitoring, that is using the rainfall data. And that is here. So here also I gave the same time period. And the blue area shows where the rainfall got more than the mean of last 24 years in 2021. And the red area shows that where vegetation, the rainfall get down compared to the mean of these 24 years. So my observed period here is June 21 to August 21, because this is the time when in June to yes, July, August. Yeah, this is the time when they grow millet and sorghum in Sokoto. So I have taken this time period for my analysis. So we can relate also that precipitation via precipitation, drought condition, and via enhanced vegetation index drought condition. So the south eastern part of Sokoto, these are the areas where the drought affected the cropland area in these LGS. So this the next which I want to present is, so this is the QR code for first application, and this is the QR code for second application here, which can be scanned and which can be used by anyone. This is public application. I mean, there is no restriction. And the third objective of mine was to monitor the flood condition. To monitor the flood condition, I use the radar data, Sentinel-1 synthetic aperture radar data. So the radar data characteristics is that radar data, the when it interacts with the area filled by water, most of the energy will be scattered here and there. It will not go back to the satellite. So values will get very low. The idea is the microwave data where this wavelength C band is around 5 meter. So it's a long wave, and this long wave when interact with water, it diffuse here and there. It not scatter back to the detector at the satellite. So the water areas values will be low, and open area, especially the urban areas, the values will be very high. So this is the difference. And this is not, I mean, there is no impact of clouds also at this energy, microwave energy. This energy penetrate the clouds. So if there are clouds, no problem. You can study the water area, and you can study the vegetation. You can study the urban sprawl also, urban areas. So using this method, I explore that which month we can look at any state, but during 2022 September to October there was a flood in Belsa state. So here I'm choosing the same time period. So here also you have to take the baseline where there is no flood, and you have to observe, you have to choose second time when there is a flood. So the first time I choose October 2020, and the second observed time I choose October 2022. So the problem is here in 2022. When you will choose these two dates, you will choose the month. The first month will be the flood free time, and the second month should be when there is a flood. So when you will run this flood monitoring, this button, so when there is a change means what? In 2020, the land was open, but in 2022, it was filled by water. So it will give you at higher confidence level, that is more than 3 standard deviation changes there. Then the red, here you can see the legend. The red area shows the drop at 3 standard deviation. That is severe flood, high confidence level. So these are the red areas where the flood was, the land was filled by water here. Red area will show you the flooded area. Using this application, you can look at the area under flood at each LGA. Here by this calculation, this is the LGA, around 6 square kilometer area was filled by water during this time. So we can download a CSV for our research or some another, flood relief fund or something to, to record this, that how much area was submerged by the water during 2022. Well, this data, it has a positive and some negative aspects also, because the water is standing for how long water is standing and the passing time of the satellite. So sometimes what happens, the water may be long standing, then it will be captured by the satellite. Otherwise, if it is very for short period of time and that period does not match with the satellite, the movement when the satellite is moving that area and the water not standing there, it will not be captured. So this is some drawback also of this, the analysis like this. But for flood analysis, this data is widely used. That is the microwave data or radar data we use for flood analysis, that how much area flood is there. The results can be validated by using the field studies, that if we say that, okay, this is the LGA covered by water or submerged by water, as much area, we can validate it by field study or by talking to the local people or local authorities. So then the final results can be accepted well. So these are the 3 studies which I wanted to share in this seminar, and this is from my side. And now I stop here. The next maybe some questions or discussion.
All right. Thank you so much. Thank you so much. You have a
You're
question?
welcome.
We have a question.
You're welcome.
Thank you so much, Prof, for your presentation. I can see that
Thank
a lot
you.
of your platforms are based on open source data, mainly from Google. So would you say it's easy to build these sort of applications with open source data, or you feel there should be more data that is indigenously built and sourced to be able to support these sort of applications?
Yeah. So is there any another question?
Yes. The question is, are there any other questions? I have a question about data presentation in particular, because I feel as if to say many times the politicians that we have to convince to do things are not really savvy with data. And I'm wondering if in the university also you are developing even more pretty pictures, pictures. Is it still too scientific? I mean, even for me who have some interest, because I'm not a drought person, I'm not so much, I'm an engineer, so I can spend the time to figure it out. But when you have a minister, you have to make a pitch for something, and you're a technocrat, and they don't get it. Is your university also doing data analytics and data visualization to help make the pretty pictures that can wow them into paying attention, that can tell the stories more easily? So those are the two questions.
Well, the first question, which the question of Alma, thank you so much for your good question. The question is, I mean, whether this data is easily accessible and these applications are made easily, because this is not only drought and flood, there are many other aspects which we can develop the application like this. So, and the next point is, what about the local data? This is public data available. The local data can be used first. Let me answer you. The first local data can be used to validate the remote sensing analysis results. First thing. Second thing is, are these applications are difficult to make? No, these applications are not difficult to develop. If there is a workshop for 2 days or 3 days, so as you know that this is the time of artificial intelligence, there is no need to learn many more things. It's possible to make the applications like this. And what we need actually in the application is, as I have what I have done here is, in this application I have used 3 layers. Okay, the first is, this is area of interest, and this shows the LGA boundaries. Then I have shown the cropland area, which is yellow color. And then this is my calculated layer, which is the standardized vegetation index in this time period. So, and now the next requirement is, we need to know the settlement also, where settlements are, where the built up area is, where the houses are there. So we can use some another data like Google building footprint. It will give us the information at building level. Each house will come to your dashboard, and you can see that, okay, as many people are living here, this is the village, or this is the hamlet, or this is the built area, or this is the city center, or something else. So such all this, and then you can add some roads, you can add some the government facility centers, like maybe hospitals, and police stations, especially the health center, are very important. Urban areas or rural areas, the settlements, when there is a flood, then how people will move from this flooded area to the hospital. It will affect their health facilities. So such type of analysis, the data is available. We can make the applications like this. And the idea is, we have to automate the things. Here, the example is Sokoto. So the same thing, if I need for another state like Plateau state, I will just click at Plateau and I will run the analysis. And then it will give me Sokoto and it will give me Plateau for the same time period. And one can do some comparative analysis here, that, okay, this is Sokoto here and this is Plateau. And in these two states, Sokoto and Plateau, what is the drought, the level of drought here in Sokoto and in Plateau state. So such type of thing, Alma, can be done for many sectors, not only for meteorology, for drought, for agriculture, but also for, we can do some analysis, we can do, and we can develop the applications in the defense sector also, where we can develop the application to get the live data from the spot, to collect all the information, where what important centers are there, and it will come direct to your office at your laptop screen. So you can go for the live operation management for any security reason. So such type of applications will be helpful for the defense management, also defense strategies and planning. So this is all about this. I hope I answered your question, Alma.
Yes,
Okay.
she said yes.
And
Yes.
And for the second question is, when we do the work, actually, whether the university or the management or the whether we are getting any support or not, is second stage. At the first stage, I think we should do some work, and then the importance of the work, obviously it will be realized by the institution and by the government institutions also. Thank you very much.
All right. Thank you very much. Round of applause.
Thank you, madam. Thank you very much. Thank you very much. Thank you, Alma. Thank you very much, especially to Alma. Thank you very much for inviting me for this lecture. So wish you all the best.
Thank you.
Thank
So
you,
folks,
madam.
we have had a very rich day of discussion, and we have come to the end of a day where our focus was on space for the SDGs. And so at this time of the day, we do a dialogue, a participatory dialogue. If I can, let me go and try to find my content.